Alright, I'm Mr. G. This is your longer than 1 minute video. But anyway, we're doing something special today. We're here with Manny.
How you doing?
In Manny's workshop. And what Manny's doing here, he's going to explain it, but I'll give you the intro, is he's going to make a part that has a harder outside, almost like M&M's. Right? Would you say it's kind of like
Yeah, it's kind of hard shell.
Yeah.
Soft inside.
Right. And so it's hard to see, but this was a part that he cut on the lathe not long ago, but he wants the outside to be hard, and inside's going to still be malleable and movable. But he's going to explain it better than me. What part of the process are we on right now?
So we're on the second part of the process, but the reason that we want to case harden this part, and that's what we're doing, case hardening, is so that we have a malleable or elastic core that's not hard, and that's good for impact resistance.
Oh.
To drop the part, maybe there's something else that hits it with some force. So the case hardening gives it resistance to moving or deformation of the surface, but that soft core gives it some elasticity, so it won't crack like a part that's hardened all the way through.
Oh, I see.
Like a cheap knife,
Right.
so to speak.
Ah.
So good knives, when they're hardened properly, are case hardened. The core is soft, the outside's hard, and the very edge is the part that's the hardest.
Got it. So the knife could remain flexible. Don't forget, something that's hard doesn't mean it's good, because if it cracks like chalk, then it's broken.
Right, exactly. So to achieve that process, we use this special powder that puts a higher carbon content on the surface of the metal. And the process is pretty simple. You heat the part up to cherry red, then take it out of the fire, apply the powder to the surfaces that you want hardened, then you reheat the part, and then quench it. And then you clean it up, then you're done. It's pretty simple.
What kind of surface are you going to get once you pull all the, like right now it kind of looks like a crusty marshmallow.
Yeah.
But is that going to come off?
Yeah, that's all the scale from when the powder hits the hot surface, it actually boils over, and it's chemically bonding to the surface. So the leftover stuff that's there actually creates a protective coating, almost like slag on a weld.
Oh.
Yeah.
No kidding.
It doesn't allow oxygen to come in during the second heating process.
Oh, that's interesting. I didn't know that. So if you guys watch some of my welding videos or any welding video, you know that when a metal is red hot, you can't allow oxygen to touch it, otherwise it'll oxidize almost instantly, right?
Right.
So you've heard of rust, obviously. Now imagine when it's hot, not like hot outside, when it's cherry red, which is around 2,700 degrees or so, I don't know, or maybe 2,600, it will attract oxygen, which will turn it into rust, which we don't want because that has porosity and little tiny microscopic holes. It doesn't have the strength any longer. So, so this is a protective layer, in a way. Is that right?
Right. So this layer protects the part from impact. It protects from deformation from impact, as well as it actually increases its corrosion resistance just a little bit.
Oh, higher carbon.
Yeah, it's not as good as stainless steel, but it is slightly higher. If you put it in salt water, you know, over time it'll completely disappear like any other piece of steel. But from moisture in the air just attacking the part, it'll get a slight amount of surface rust and then neutralize. It won't go any further.
Now, something we didn't mention is, what is this part?
Oh, this is a special request by a friend of ours that's building a bicycle and he needs.
No, it's a motorcycle.
Oh, it's a motorcycle. Oh,
but it's similar. The neck is similar.
Right. So he's pressing his neck bearings in to the neck tube.
Right.
And the specific part is the race, and that's a conical race because it's a tapered bearing. So he needed a special size for that bearing race, and we're making him the special size die.
Nice. And so I lent him a tool called the Park tool. I think it's an HH something 2 or something.
It's an
HHP-2. But the die that they gave, which is the shape of the press, didn't fit his needs. So he gave us some drawings, and Manny was nice enough to cut it on the lathe, and then now he's going to case harden it, which is what you need for this application.
Right. Well, I didn't really know if it was necessary to case harden the part.
Right.
But being as how the original die for the tool kit is case hardened, might as well just follow the trend.
Right, okay, right.
Even though it might just be used once.
Yeah.
It doesn't matter. Might as well do it right.
Right. And he's doing it on, I think it's a Yamaha or something like that. So maybe it's universal. So when he's done with it, he could lend out the tool to a friend or whatever. But now, how do you know it's ready for its second coating?
You can tell by the color of the slag. So if you look on the opposite side of where the flames are touching, or we could just move the fire. See, it's not quite there yet. It's got a little bit of a glow to it, but it still has a little bit more to go.
Yeah, okay.
So you see, if I take the flame away, I don't know if you could tell in the video, but it looks like there's glass on the part. Effectively, that's pretty much what there is on the part right now.
Yeah, I do see it. It's kind of shiny.
Right.
Hard to see in the video, but I saw that. What's this fancy smashy rotating thing?
That's a homemade turntable for welding. So you can control, it's a DC motor, DC drive. You can control the speed here, forward, reverse. Pretty simple. I've got two of them.
Do you make cakes on that?
No.
You don't decorate cakes?
No.
That's what my dad would do if he saw this. He'd go, oh, it's a turntable.
That's what it is. It's called a turntable.
Yeah, we used to have that. You could decorate the cake like that and whip around real quick. Except it was manual. Could have used that. Where were you when I was a kid working at my dad's bakery?
Working under a hood, probably.
Oh, yeah. Pretty cool. Can we get a look at what this looks like?
Sure.
Okay.
Yeah, whenever you use this stuff, use it in a well-ventilated area. It's not good to inhale.
Okay. Are we close?
Yeah, I think we're there.
All right.
All right.
All right, we're going to stick around for round 2 here. Whoa. I didn't know that was coming.
Yeah. Instant steam.
I didn't know. I thought you were putting more of this on there.
No. That's it. That's it.
Wow.
So like, the instructions are right on here. They're pretty simple. You heat it up, you coat it, reheat it, then quench it and clean it, and you're done.
Let me tell you, people, that's why you wear glasses in the shop. I was standing right next to that. I felt a little piece of water hit me. I didn't know that was coming. But that's okay. So now, by quenching it, did you harden some of the inside metal as well?
So yeah, there's a certain depth that the hardness goes. So this powder should give us a Rockwell of about 65 to maybe 70. Probably not that high, but anyway. It'll go down to a depth of about 5 thousandths to that hardness.
Oh.
And then gradually taper off as the depth keeps going.
Okay, so just so everybody knows, 5 thousandths is kind of like 2 human hairs.
Yeah, it's not very thick.
Yeah.
The extreme hard layer is very thin, but that's all it takes to get the results we want.
Nice.
Now we're gonna test to see if this actually did get hard.
Oh.
Just take a file.
Oh.
Just take a file and we'll put it on a non-critical part of the part here, just in case it didn't get hard. And yeah, it skips right off of there. It's not biting into that material at all.
Okay, so let me explain this a little bit. I could see that it got a little shiny, but there's no material coming off.
So that shine is because I'm actually cleaning the slag off of it.
Yeah.
When I wire wheel apart, it'll all come back to a shine.
Right.
Just like that there. See that? But it's super hard. There's nothing coming off of that.
Wow.
There is no
amazing.
Material coming off at all.
So that means it's as hard or harder than this.
It's harder than the file.
And the file is like chalk. It's the reason why this is hard is so you can cut other softer metals.
Right.
The analogy that I always use is like, imagine if you had you wanted to cut butter with a butter knife, but the knife was made out of butter. The two would just mush. They wouldn't cut one other. What you would need is one of them to be either colder or one of them to be softer or harder.
Right. So this is the material that we originally made the part from.
Oh, good. We have a comparison.
Right. So this is unhardened 4140.
Okay.
And the file test is more of a feel. People say that you can hear it, but it really is more in the feel than it is in the sound. And you can see.
Oh,
and you can hear the difference.
Yep.
But you can always feel it more than you can hear it. And I'm totally biting into that material.
I hear it going.
Yeah.
Yeah, like, okay, it's hard to describe this at home, but instead of it going like skipping across on ice, it's digging in like cleats would dig into soft dirt.
Yeah. See, this is skipping right across there.
Right.
As opposed to doing...
Yeah. Yeah, totally different. Amazing. All right, cool. That was a great demonstration. I love comparisons because that really brings it to life, you know?
Yeah. So now all we got to do is wire wheel this thing and it'll be done.
All right, thanks, Manny. All right, we're here at Manny's Dream Shop. That was case hardening 101. Hope you guys got something out of that. That was interesting. I've never seen that before. And he surprised me with the quench, and that was what was coming. It was good. All right, so see you guys later.